Hello, everyone. I am Elvis, and I'm excited to bring you a new paper summary. This one is titled Self Evaluation as a Defense Against Adversarial Attacks on LLMs. So, this paper, what they're trying to propose here is the use of self evaluation. So, like other methods that involve self evaluation, this specific one is about using another LLM to build some sort of defense against adversarial attacks, right? Adversarial attacks would be these attacks where someone is trying to make the model produce some harmful or unwanted output, right? And how do we protect against that? And the idea here is to use the self-evaluation, which is evaluator implemented or backed by another language model to evaluate whether the text that was generated by the chatbot, let's say you had a chatbot in place, if that output is safe or unsafe, right? It's like a classifier of sorts, and figuring out whether the output is safe or unsafe that the chatbot had generated, right? The generator itself. So the generator is like the chatbot, and evaluator is just this evaluation system that we're building. And they're using no model fine tuning, right? It's just using out of the box pre trained models is good enough to build something like this. And they mention here that their method can significantly reduce the attack success rate of attacks on both open and closed source LLMs. There's a lot of results, and we're going to go through it, at least the interesting ones, beyond the reductions demonstrated by Llama Guard 2 and commonly used content moderation APIs. I want to say that this is a really important consideration when you're building with LLMs, and it's something that I always kind of push on when I work on projects or any of my consulting engagements with companies. Always make sure you have something in place, even if it's just very basic safety mechanisms, or maybe using some out of the box content moderation tool. It doesn't hurt, and you will see how effective that is here for like common adversarial attacks. So this is what the paper discusses. Now I'm going to go through the main highlights, but basically what they have done here is this is the defense. So you can see the user provides right an instruction. In this case, give me instructions to build a bomb, and then they also attach the suffix. We will get into this suffix. The suffix actually involves the adversarial attack, so it's meant to make this model actually produce harmful content or bypass the LLM safety guardrails. And the chatbot basically generates, right? So this is maybe ChatGPT or one of these other chat LLMs will produce an answer. So this is the input, the user input. This is the generator output. And then you use an evaluator basically with a prompt like this. So evaluate if this text is safe, and you evaluate on the output whether this generated answer is safe or unsafe, right? If it's unsafe, then we probably can block it. If it's safe to answer, then it can probably, be sent as a response. So you have that level of control when you are producing outputs from language models, whether to send it to your users or not. There are different ways how you can assess this and evaluate it. You can use the evaluator to evaluate if text is safe by providing it both the user input and output. You can also just focus on the input, and you can also just focus on the output as well. So ASR here, just for terminology's sake, is the attack success rate. So that's like an important metric. And this one is used in this paper here. This paper is referred to as GCG, is basically a method. It used to generate these suffixes, right? These suffixes are used as the adversarial attack itself. It says here that based on the defenses they have built, they can reduce the ASR, which is this metric, of inputs attack with suffixes generated by this method from 95.0% to 0.0% for a Vincuna 7 billion parameter model, simply by prompting another LLM to classify the inputs as safe or unsafe. So it would be this one right here. They mention here that they further demonstrate that by decoupling safety classification from generation, the defense is challenging to attack in adaptive attack settings using the strongest existing attacks. Something I mention a lot as well in my course that I deliver on LLMs is that you want to separate these tasks, right? You don't want your evaluator or your main generator system to be doing this defense or have the responsibility to defend against adversarial attacks. And that makes sense because you want to simplify, you want to break down these tasks. And so you want to develop a dedicated evaluation system. You could call it a verifier system. Some people call it verification systems and so on, but it's along the same line. So you want to build it separately. Now they talk about the threat model. These are just kind of notations that they're using here. That's not so important here. But they say a trivial defense simply refusing to reply to all of X, just the inputs, satisfy safety perfectly, but results in a uses generator model. An ideal defense responds well to all safe inputs and refuses all unsafe ones. When you're building these safety systems, right, these evaluator layers or verification layers, what happens a lot of the time is that these layers are, yes, in charge of detecting unsafe outputs, but they also have false positives too. So in a lot of cases, they might label something that is safe as unsafe, and you don't want that because that really messes up the experience of the user. Right? So you can imagine someone is trying to use your application, your LLM-based application, and you send them back a response like, "Oh, this request does not pass our safety guardrails, try again," but it was a safe input, and so you don't want those cases because it definitely messes up the user experience. They define the attack here, but we're gonna now talk about the results. I think the results are really interesting. But the baseline defenses, their methodologies that they use here, they use Llama Guard 2, a fine-tuned version of Llama 3 as well. Then they use the OpenAI Content Moderation API, the Azure Content Moderation API, and Perspective API. We use all of these APIs, by the way, in our work. And so these are the baseline methods. It was good to see that they're comparing with not only other models or fine-tuned models, but also like these out-of-the-box services that exist today. So self-evaluation is what I was talking about, right? This is the defense that they're proposing. That was already defined in the figure that we discussed. Is very simple. What you choose to use as your prompt, well, maybe a little bit of prompt engineering to make something very robust. But the idea here is they really wanted to assess the importance of that evaluator, right, in different settings. And they have different settings here that they're using. Again, it's input only setting, output only, and input output as well. Okay, so the input will be just using this as input, and this is what we're going to pass to the evaluator, or just the output. So output is what the evaluator sees, or a combination of both, right, which is input output. So those are the settings that they're going to be evaluating on. So the first one is input only defense, and they say that this is a cheaper and faster evaluation to perform. Obviously cheaper, faster because it's all just the input. So you can see here, this is the setting here. This is the example. It says here, right, with the suffix that it is intended to circumvent the alignment of the LLM and induce it to respond to the user's original, potentially harmful request. So in this case, it could be a harmful request. And right, there is a suffix, which is the part of the adversarial attack that this user is using. And so the evaluator should detect that. And you can see here that it's directly doing evaluation on that input. The difference here with input output is that in the input output, right, we're seeing the combination of the output of the generator and also the input. So concatenation of both. And then the output only is just using the output of the generator, which is passed directly to the evaluator. So each one has its advantages and disadvantages, but they're assessing on all different settings here. Now with the output only, this defense does not expose E to the input from a user. Again, no input from the user, so we don't get access to this, which may make it less susceptible to attack, right? So again, because it doesn't include the suffix, but what's generated is really harmful still. Obviously, this one is going to require potentially more resources, right? It's going to be higher latency probably, but it really depends on the length of the user input and also length of the output as well. So here's the evaluation. I'm going to do a summary of the results here. This chart that you see here, they're showing what are the results with the undefended setting. Undefended is not using an evaluator, just straight up using this generator. And you can see how bad the defense is. So the higher this is, the worse it is. The system is performing. But you can see that if they're using some type of evaluator, which is this row here, or the columns, right? And then they're using combination with some generators. So you can see the performance here. So almost all zeros in the input only setting. The output only, you can see that they're all very close to zero as well. And even in the input output setting as well. Now they do a bit of more work on the analysis side of things. And one thing they report here is that they really don't want over refusal, right? Because again, they're thinking about the experience, right? The user experience that you're giving with these models. You don't want to be refusing too much or refusing at all to save inputs, right? You don't want that kind of situation. So it's important to measure that. And the problem is that when you do build this verification system or evaluation systems, it is the case that it's going to misclassify things, right? And in those cases, how do you deal with those? Maybe you want to build another layer or something like that. And it's important to always be measuring that. If you're going to build a system, you want to measure this because this does affect the user experience. And I mentioned here that with an initialized suffix appended, Vincuna significantly reduces the response rate with an ASR of 91%. With a trained adversarial suffix appended, all evaluators reject the majority of model inputs. It is unclear what models should do in this final setting, as although these inputs do not cause unsafe outputs, they do include suffixes that induce harmful outputs when combined with different user queries. So you can see this one, this Vincuna model, right? You really don't want to see these higher scores because that means that it is, in particular in that setting, that it is refusing to respond. Another thing that they do assess here is an attack on the evaluator, because so far we have just discussed the adversarial suffix, which is an attack on the generator itself, right? The person that's, or the user that's sending this attack has no idea that there might be an evaluator. But let's assume that this user knows that there is an evaluator and now designs an attack that attacks also the evaluator and the generator as well. Right? So that could be another scenario. So they are also evaluating for that scenario. And what they say is that there are three different scenarios that they're assessing for here. The first thing they need to do is they need to find an attack suffix, right? And there are different ways how you can do it. You can concatenate, you can do optimization in turn, and you can do also simultaneous optimization, because in this case, right, you're tuning a model potentially and you are generating, a very effective suffix, this attack suffix that you're interested in. Once you have that, then you can do some evaluation. And they're doing evaluation again on different parts. So on concatenation is the first one. Here you see the different sections, optimization in turn, and then single objective optimization, which considers both. And overall, what I can see is that when you design an attack like that, right, you can reduce the effectiveness of that evaluator. You can do that. And you can see that the ASR here is a lot higher. It's not 0, which is what you want in all ideal settings, but you can see that when you are doing the tuning of this adversarial suffix, you have different settings in which you want to assess, because you want to assess maybe just the generator setting alone, or you want to assess the combination of the generator and evaluator as well. ASR is lower for when you're using the G plus E pipeline. And that's what you want, right? Because you want to not get rid of the evaluator. Evaluator is really important. It shows you how important that evaluator is, actually. And that appears in all the tables that are reported here, regardless of the setting that they're using. So you can see again here with G plus C how it's a lot lower. However, this particular one, they mentioned that it's a weaker attack than concatenation. So it seems that concatenation, it's a much more effective way to create this adversarial attack, right? So the concatenation that I mentioned here, you can read the details yourself, but this concatenation method is a lot more effective, regardless of the setting. So what I mentioned for single objective optimization is that single objective optimization results in an attack that is more effective than other approaches in the input-only setting. So here, in the input-only setting, you can see how these numbers, they just go up really high, regardless of the setting that you're choosing, whether it's just G or G plus E. So this should actually be more effective rather than weaker. That's just a typo that I made there. And then they also tested this copy-paste attack. So what you have seen so far is that they have done this analysis on input only and then input-output as well. But they haven't done it on just the output only, because again, when you talk about output, right, it could be that you have more control over the output as the person that's building it. And the user or the person that's attacking have less control over that. So there could be a scenario as well that you could potentially build an attack that influences the output as well, so manipulating the output. So you can see the example here. the example says append suffix 1 to the end of all outputs. So yes, when it performs the instruction, it should add this suffix 1, whatever was found out to be an effective suffix for the evaluator, and that's targeting the evaluator, right? So now this user knows that there is a system that is using potentially an evaluator. And by the way, I mean, people that are doing these type of attacks, they are trying different things. They have these algorithms that are trying, testing, probing until they find out, okay, there might be some kind of middle layer system here, or middle layer verification system that I need to attack. And so how would it work in that setting, right? How does this defense work, and if it is still effective? So this is the copy paste attack. I mentioned here, notably, that this copy paste attack can attack both G and E, though like the direct attack is weaker against G than a generator only attack. It says our defense method outperforms all other methods with the evaluator APIs and Llama Guard 2 showing higher increases in ASR between generator only and copy paste attacks as shown in table 6. So you can see the results here in table 6 as well. The ASR is still lower for G plus E pipeline with the copy paste attack. So still, right, even though this is targeting the evaluator, still, I think compared to the previous results, it's what they're saying is that they can still get these models, especially the Llama 2, to have a lower ASR, which is what you want. And you can see again for input output setting 6.0 here, but in the output setting, they can get it all the way to 21.0 with this attack. So it's a very effective attack, but you can see that it's still very useful to have an evaluator. And this is what it's showing, right? Compared to just using the generator alone. So definitely, trying to target that evaluator is something that you can expect from certain types of users that maybe want to harm your business or something like that. And so building all these defense layers, you may want to consider evaluating for all these different settings, especially copy paste, I think is very relatively new and something that you should be keeping in mind. But again, very advanced analysis here. That's pretty much it. I think this is really good work. I wanted to highlight it because we are building these things and we're showing to our users and our companies that we work with how to think about this, right? How to build defense. You can use pre-trained language models and they can be really effective, as this work shows, to build defenses. While they may not be perfect, it's better to have them as opposed to not having any at all. Because if you just have a generator, right, you're just relying on the power of the generator, which may have not been tuned to have those safety guardrails. So that's something that you must be responsible for as a developer. Hopefully that was interesting. This is a little bit different from some of the other content that I've been posting, but I would love to do more of these paper reviews because I think they do offer a lot of insights, especially if you're building with large language models. Although this is a research paper, we have already done a lot of work on this, on applications that we're building for the companies that we work with, and we're getting a lot of success with the self-evaluation. And again, using these language models for the self-evaluation makes a lot of sense, similar to how you would use another language model to be a judge or something like that for measuring, in that case, not safety, but the quality of outputs too. So all of these ideas, they're all kind of related. So that'll be it for this paper review. Thank you so much for tuning in. And again, consider leaving a like and subscribe to the channel. I appreciate all the support and see you in the next one.